right, let's say we have this situation. What if you invested $1,000 in a savings account that had 6% annual interest and paid that interest every month? How much money would you have after 2 years? Now we can use a formula, well, I'll get it in the next slide. We can use a formula that's very similar to the exponential growth formula. Okay, but it's tweaked just a little bit because we've got this every month. Okay, and it's called compound interest. And it's, like I said, it's very, very similar, where P is the initial amount, R is your rate, N is how many times you get your interest every year. So it's how many times your interest is compounded in a year. Okay, and then to the NT power. So let's look at that example again. And here we have P times 1 plus, we've got our rate over N to the NT, I did TN, but let's do NT. Okay, so it's just, we're throwing N into this. All right, so I've got my initial amount, $1,000, 1 plus my rate, which is 6%, so 0.06, divided by how often I'm paid in a year. This says I'm paid every month, so I'm going to put 12. And then it's 12 times 2 years. Okay, so when I'm doing this on my calculator, again, what I do is I start here and work my way out. So I do 0.06 divided by 12 plus 1 to the 24th power, because 12 times 2 is 24. And then I multiply it by 1,000. So my answer is $1,127.16. So that's not, I mean, it's $100. You make $100 in 2 years. Well, that's not too bad. And if you let it sit in there for a while, then it grows. And that's what this graph is. This shows you, you put in your $1,000. Now this is 10, 20, 30, 40, 50 years, but look at how big it gets. I mean, it gets 2 years is right in here, and you make just a little bit. But if you left it in for 10 years, you would have almost $2,000. But it's exponential, so it grows really fast. Okay, so here's a couple that I'd like you to try. So go ahead and pause your video now. Okay, so now we deposit $100 in a savings account that earns 3% annual interest compounded monthly. Okay, so here again is my formula. Okay, and I'm going to put in $100, and I have 1 plus my rate, 0.03, divided by, it's monthly, so it's divided by 12, to the NT power, so 12 times 15 years. All right, so now when I put this in my calculator, I have 0.03 divided by 12 plus 1, and then I do it to this power. I'm going to put in parenthesis 12 times 15 close parenthesis, and now I multiply it by 100. So I have $156.74. Now this problem, hopefully you noticed when you were doing it, this problem is exactly like the other, but it's compounded semi-annually. Now what does that mean? It means it's twice a year. So which one do you think is going to make more money? The one that collects interest or gives out interest every month, or one that just does it twice a month? So let's look and see what we've got. We've got 100 times 1 plus my 3%. This time divided by 2 because it's twice a year. And then here we have 2 times 15. So 0.03 divided by 2 plus 1 to the 30th power times 100 gives me $156.31. So after 15 years, you know, it's not a huge difference, but if this were a higher interest rate, and if somebody was investing, like say $1 million, that's going to be quite a lot of difference. So it's best to get something that's compounded more often. Maybe it's compounded daily or compounded hourly, then that number gets bigger. So that is what I have for you. As always, if you have any questions, let me know.